Hey, welcome back, Warhawks. This is Mr. Mark. We're going to go over 2.2. We're going to learn about some special angles. We're going to compare postulates and theorems. Not too much of a difference between these two. And then we're going to actually use some new postulates. So let's get started. We got a new smartboard that I'm using today, so I'll be able to write on the board. Hopefully it goes pretty well. It is a little difficult because I can't see the projector when I put my hand in front of it. Kind of blocks it, so just bear with me if my writing's a little off. All right, so complementary and supplementary angles. Very similar terms. You can hear how they sound the same. Complementary angles are two angles that add up to 90 degrees. Supplementary are two angles that add up to 180 degrees. So if you add these two right here, they add up to 90 degrees. Therefore, they are complementary. If you add these two right here, you get to 180. They are supplementary. The way that I help myself remember this is C comes before S, and 90 comes before 180. Therefore, complementary goes with 90, and the supplementary goes with 180. These angles do not have to be side by side. We will get a special name for that. You could have something like this, where you have 25 degrees, and then over here you have 65 degrees. These two angles would still be considered complementary because they add up to 90 degrees. All right, so our next problem, how can we use this? Well, we've got angle ABD, which is right here, and we have angle DBC, and together they're going to add up to that 90 degrees. But they want me to figure out what is just the measure of this angle right here. They want, what is this angle right here? Well, I know that if these two angles are complementary, they have to add up to 90 degrees. So I know they're 90 because that little square right there. So they're complementary. So angle ABD plus angle DBC has got to equal and then 90 degrees. So I went ahead and I worked that out for you. This right here, this is from right there. This is the measure of the other angle, and we added those two together. I did the algebra here already pre-ahead. I put like terms close together. I did this 2x and that 3x. I put them together, put them close together. Combine like terms, you get 5x right here and 35. I then subtract 35 from both sides. And when you do that, you get 55. I'm then going to divide by 5, and that's how I got my x to be 11. Now notice, this is not circled. It's not saying that that's final. That's not my answer, because they didn't say solve for x. They said, what is the measure of that angle? So I have to use this x that I found, and I have to plug it in. I plug in and check, and I see that 2 times 11 is 22, plus 15 is 37. This is my actual answer. So 37 is my actual answer. Now check to make sure this makes sense. I plug my 11 in not only there, but I plug it into my other angle, and when I do that I get 53. The reason I can check this is if they both add up to 90 degrees, which they're supposed to because of this little box telling me they're 90 degree angle, 53 plus 37 is 90. I know that 37 would make sense, and also my x being 11 makes sense. It all adds up. All right, we're going to do the same thing with supplementary angles. If you want to give yourself just a minute, pause the video and try this out. It's very similar to complementary, except supplementary, we know this is going to be a straight line, and a straight line is 180 degrees. So angle AOD is right there, and angle BOD, and those together are going to add up to this 180 degrees. Okay, so I have it worked out for us. Notice this right here is this first angle plugged in. This is the second angle plugged in, and they are adding up to 180 degrees. I did the math for it, and combine like terms. 6x plus 4x is going to be the 10x. 40 minus 10 is going to be that 30 that's right there. I'm going to subtract 30 from both sides. I get 150, divide by 10, divide by 10, x equals 15. And again, that's not my answer. My answer is not solve for x. It is what is the measure of an angle. So I have to plug in for BOD, which was this second one. So I had to take 4 times 15, which is 60. 60 minus 10 is 50 is my true answer. But I want to check to make sure it makes sense. So I plug this 15 back into the other equation, and I get that that other angle is 130. When I add 130 and 50, it gets me to my 180 that I was supposed to get. So 50 makes sense. I know when I leave this class, I got that question 100% correct. There's no other way that that would work out. They're supplementary, they're adding up to 180, and I got my two angles. All right, adjacent angles. Adjacent angles share a common vertex. Common vertex, right there. That's pointing to this guy right here. And then a common side, which is right here. So for this angle right here, the common side would be ray OB. That's their common side. It's right there. So that's the common side. These guys are not adjacent. Okay, I got a clear example of a non-adjacent. I know it's kind of blurry, but they're not adjacent. They're not touching. There's space in between them. Not adjacent. Adjacent, they're touching. There's that common side that they are sharing. All right, so let's go ahead and name some angles that are adjacent, that are supplementary. So if we did this, it would be angle APD and angle DPB. If you notice, I'm going APD, and then wherever I leave off, I'm starting there, DPB. And this is their common side right there. Now, that's not the only one that we can do. We erase this. We can do this angle right here and add it with this angle right here. And so that would be angle APC and angle CPB. Again, notice where I'm leaving off is where I'm starting at. So this is their common side that they share. And those angles are supplementary, and they are adjacent because they are sharing that common side. So what is the special relationship between these guys? Sorry, I had to pause the video for a second. The slide got deleted. So linear pair is something that is actually two angles that are combination of the two ideas we've already talked about. They are supplementary, and they're also adjacent. So when you combine those two ideas together, you get what's called a linear pair. So when you have a straight line, and you have like the example that we just did, these guys, if I label this so the actual angle ABC and angle CBD, these guys are an example of a linear pair. They're supplementary because they add up to that 180 degrees. They are adjacent because they share a common side. When you get those two ideas together, it is called a linear pair. So actually, the examples that we did all before, all of these guys, I'll erase this, all those examples that up here that I did before were examples of a linear pair. All right, so what special relationship do these guys share? They are supplementary. They are not a linear pair, what we just went over. They are not that because they're not adjacent. Remember, adjacent means side by side. They have to be touching. These guys are not touching. There's no common side between them. They're not sharing that. So therefore, they're not adjacent, which means they're not a linear pair. Linear pair means you have to be both supplementary and adjacent. You will use that throughout the entire year. We'll use linear pairs quite often. All right, so vertical angles. Vertical angles are non-adjacent angles formed by two intersecting lines. So A and B, right here, would be examples of adjacent angles. They share this common side. We are not talking about that anymore. We are now talking about vertical, which kind of means like opposite of each other. So right here, you see this A and that A. They are vertical angles of each other. And this B and this B are vertical angles of each other. When you have vertical angles, you're going to notice right here that vertical angles are actually always going to be equal. So you have 46 here, you have 46 here. They're always going to be across from each other. And notice still here, if you add those two up, they're going to equal that 180. And angle IEF, and angle FEG are going to be supplementary. They are adjacent, therefore they are a linear pair. I'll erase that so you can kind of see that a little better, hopefully. So you have linear pairs up here, you have vertical angles, you have supplementary angles, all those kind of things can describe a lot of that. Right here, this diagram down here with the numbers is actually very easy. Angle 1 is what you can call this top angle. Is congruent, this is a new symbol that we're using in geometry, is congruent to angle 3 because they're across from each other. Vertical angles are always going to be congruent. And angle 2 and angle 4 are going to be congruent also. The other thing you have to know, we talked about this, is that there's other relationships up here. We know that angle 1 plus angle 2 has to equal 180 degrees because they are supplementary and they are adjacent. So actually, you could call them a linear pair if you wanted to. All those words describe the relationship between those two angles. So make sure you're studying those vocab words, guys. They're going to come up quite often, and we will need them. All right. So how do I solve for this? Well, when we have these guys right here, you can see that this angle is vertical to this one. They're across from each other, and we know that vertical angles are going to be congruent. So down here, I set those two things equal to each other. Now the rest, what I'm doing is I'm combining like terms. So I want to keep my x positive, so I went ahead and I moved this x over to this other side. So I minus x first and minus x, and that's how I got 3x down here. I then went ahead and I added 5 to both sides, and that's how I got 21 equals that 3x. Divide by 3, divide by 3, and I get that x equals 7. Now this answer was actually x equals 7. I'm done. The reason that I am done with that answer is because it actually said what is the value of x. It did not ask me for what is the value of the angle. Now I can check my work because I know if I plug this x in, it should be, when I plug it in here and when I plug it in here, those values should end up being the same number. So if I check that, x plus 16 or 7 plus 16, which is 23. So this measure, the angle right here is 23. This one better be 23 also. And when I check that, I get 2 times 7. Sorry, not 2. I get 4 times 7 minus 5, which is 28, minus 5, which is a 23. They both end up being 23, which better happen, so I know that 7 is the correct answer. Again, I'm just checking my work so that before I leave the classroom, I know I got that question 100% correct. All right, postulates and theorems. The only difference between postulates and theorems is postulates are statements we accept to be true without proof. Theorems are statements that we can prove. The way I kind of remember postulates is because of my daughter, she'll ask me a million questions, and they usually are why. She'll go, why, Daddy? And I'll give her an answer, and she'll say, why? And eventually I run out of reasons why, and I kind of have to just say, because you just need to trust Daddy. And that's kind of what I'm saying here. When I give you a postulate, I'm saying just trust me on this. We accept this to be true. We can't prove it. So that's what we're doing. We're talking about without proof. You just need to trust us on this. With theorems, I can actually show you why it's true. So here we go. We got a postulate we're going to use. Linear pair postulate says if two angles form a linear pair, then the angles are supplementary. We talked about that. So if I tell you that they're a linear pair, you know that they're going to add up to 180 degrees. The segment addition postulate says something very similar, very easy to understand, hopefully. If point B is on segment AC and between points A and C, then AB plus line segment BC is going to equal AC. These guys should have line segments over the top. So here's what it's saying. If you add this piece of this line segment and you go all the way to B and you start at B again, you all the way to C. My drawing's off a little bit. If you add those pieces right there, you're going to get the whole line, which makes sense. And that they broke this down into if you have 4 here, you have 10 here, then the total from here to here is 14. That's the segment addition postulate. Here's how they can ask you to use this. We're not going to go through all the math because I want to try to keep this kind of short. The rest will be algebra, but to set this up, if you know that RS plus S to T should and better equal R to T, from here plus here should equal the whole thing. And that's what I did here. So what do we replace the line segments RS with? Well, it's 5N plus 30, and that should equal, what's the whole thing? The whole thing is 9N minus 5. You should combine like terms. Move this over to the other side by minusing the 5. Move this over by adding 5. Move that over by subtracting 5N. Move this over by adding 5. And then combine like terms and figure out what N is. All right, I added angle addition postulate. Says if point D lies in the interior of it, so if we have point D and it's in between this angle, this bigger angle right here, we know that if I take this smaller angle right here and I add this angle right here, that I will get the entire large angle. And that's all the addition angle postulate is saying. So how can they do this? Again, it'll be something like this. We know that this angle right here is 4x plus 2. We know that this angle right here is 3x minus 7. And we know this whole big angle, AB, this should be D. I'm sorry. Hold on. We know that this should be a D. And so it should be angle ABD. That whole thing from here to here is 121 degrees. So I'm going to help set this up. I'm not going to finish the algebra. I'm running over on time anyway. So if I take these two angles, the first one is angle ABC, and I add it to angle CBD, I should get the whole big angle, which is angle ABD. And in math terms, the ABC is equal to 4x plus 2. And then plus, I'm going to add the other one, 3x minus 7. I'm trying to color code this so that you can see what's going on. And then that should equal my 121. Again, you're going to combine like terms. I'm not moving from one side to the other side, so I can actually say 4x plus 3x, which is 7x, and then I'm going to add a 2 and a negative 7, which gets me to negative 5, and that equals 121. And then add the 5, and you can finish the rest of the problem off. So that's going to be it for that chapter, or just about. So that's that slide that I was missing. That's going to be it. You guys have a great night, and I will see you tomorrow in class, and have a good night.